Hey everyone, welcome back to Tech Junior Tutorials. My name is Lee Warwick Jr. and today we're going to be talking about an Advent of Code retrospective. So I've finally finished all the puzzles. I got the 50 stars. You can see that here. Finished Advent of Code, went through all these puzzles, attempted all of them on my own. A couple of them I had to cheat on. Particularly day 22 was like an egregious example of this is a math problem and not really a coding problem. But otherwise, with just a few hints here or there, I was able to solve all the problems. So, just about me, I'm a front end developer, really a JavaScript developer, like full stack JavaScript. So, primarily, I do a lot of front end stuff, but I also work with Node and I work with AWS and Lambdas and that sort of thing. So full stack JavaScript, haven't really branched out into any other languages. I've done a little bit of SQL. I know my way around databases like MySQL and Mongo, DynamoDB, that sort of thing. So I've been kind of in that realm for a long time. Well, not really a long time, a couple of years at this point, but not a super experienced developer by any means. Some people wouldn't call me a junior anymore, but I certainly, like, by years of experience, feel like a junior developer. So why did I do this challenge? I belong to a couple of communities. So first one is the Orlando developers community. I live in Ocala, Florida, but I went to a boot camp in Orlando and met a lot of other developers in Orlando. I was lucky enough to join this channel, which led to my first position as a developer. So I love being a part of this community. Also, Coding Blocks is a podcast about coding, obviously. They have their own Slack channel up here that I've joined. Joe Zach is one of the hosts of Coding Blocks and also lives in Orlando. So I met him through my own meetup and had him come and give a talk. And he has done Advent of Code before, so he talked to me about it a little bit. Also, Chris Biscardi has his own Discord. We interviewed this fellow for Tech Junior. He was an excellent guest, really smart guy. And so he has a newsletter that I signed up for, and he said, hey, join us on the Discord channel. So I went ahead and did that. And all three of these communities got together around December, and they said, hey, Advent of Code is coming. Who's in? Basically. So I didn't know what it was. At the time, I was going in blind. I just said, okay, it's like coding puzzles. Let's do it, I guess. And I had been wanting to start a YouTube channel for a while and do code tutorials. So I figured if I do this and then post my videos to YouTube, we'll see how it goes and maybe I'll learn something along the way. I ended up learning a whole lot of stuff. I didn't know if I'd be able to finish it because it's kind of notoriously hard. So the creator of Advent of Code, Eric Wassel, this is the about page for Advent of Code. He says you don't need a computer science background to participate, which is good because I don't have one. I started off as a Japanese language major in college. That's what I graduated with. I started with chemical engineering, which I hated, and then I moved over to computer science and thought that I would get a degree in that. But long story short, they taught us Java in 2006, which is a little bit different from Java today. It wasn't fun. I was learning stuff like binary and hexadecimal and recursion and stuff when I hadn't even written a program before. So I dropped out of that. I decided I was going to pursue language. Always loved Japanese, so got into that. And then after college, became a fireman and a paramedic, and then eventually a nurse. And the whole time looked back and thought, man, what would it be like if I had stuck with programming? And so by that time, boot camps had exploded, and I went and did one of those here in Florida. Loved it, and then changed careers and became a programmer, and haven't looked back since. So I don't have that computer science background. I don't know a bunch of algorithms and data structures. I've never even needed that as a JavaScript developer, at least not in any explicit way. Like I know kind of them and of their importance and when to reach for them, but I've never had to implement them, and I just don't really reach for that stuff in my day to day life, even as a JavaScript developer and working in back end and front end and stuff. But they do say you need problem solving skills, which that is true. Computer science background, mostly true. You definitely need fancy, well, not fancy, but you need working knowledge of basic data structures and algorithms to get through some of these problems. You don't necessarily need to know what they are, and so like you don't need to write a bubble sort or anything to get through, but some of the problems will require you to write something that is efficient enough to finish in a reasonable amount of time, and so you'll need to get through and find a solution that does that, and that may require, it may be easier if you knew some computer science stuff. So the reason that I ended up doing it ultimately was because I wanted to learn Python. So I had struggled to learn it for a long time. In fact, when I was a nurse and I wanted to become a developer, Python was like super popular and still is. And whenever you do a Google search for like what language should I learn, Python's going to be one of the ones that pops up. So I had started with like Codecademy or something like that and looked at Python and thought that I would start learning that. And most tutorials start with like, here's a variable. Here's how you make a dictionary. Here's how you make a list or something like that. And then here's how you add to a list. And that stuff is super boring. So look up a Python tutorial real quick. Yeah, so here's a good example. When you look up code tutorials like this and you're like, okay, I want to learn Python, it starts with a hello world example. And you're like, okay, here's how you do a print statement. And you're like, all right, next thing. Here's how I do a variable. Here's the types. So here's a float, here's an int, here's a string. Here's basic operations. Right, and so by the time you get through this, you spend like 15, 20 minutes doing like conditionals and whatnot, and maybe you get down to as far as functions or something like that, and you're just totally bored with it. So that was my experience trying to learn Python previously. Trying to do stuff like this, and even like, oh god, I don't even know what I did there. Even JavaScript, same thing. Any language, like once you're familiar with the absolute beginner basics of something, like trying to learn a new language by going through a tutorial like this and learning the syntax is maybe like the most boring thing that I could think of to do. So learning JavaScript through the bootcamp was not boring because they take you through and teach you projects. So the first thing that you do is build a website, and that's very visual. Even though you're working with HTML and markup and whatnot, it's fun because they're like, okay, build a website for your favorite band. Okay, now build your portfolio website, put like an about you section in there. So there's a lot of creativity that goes into it, even though you're learning what could be considered as boring stuff like not linked list, like ordered lists and unordered lists in HTML and stuff like that. But I don't know, I just ended up having like a blast doing that kind of stuff. And so for Advent of Code, I had done a little bit of Python before. We did a workshop series at my meetup, which is the Orlando Junior Developer Meetup or Project Codex. We had some past events where we did some Python workshops. So we had a fellow, Michael DuPont, who is a developer for Disney down here in Orlando. He works in like R&D department for Disney, and they use Python for a lot of stuff. So he runs the Orlando Python group, and so we got together and did a couple workshops over some weekends on like, here's an intro to Python, here's how you build like a CLI app, here's how you would get a data set and load it in to like turn that into a database, and then like how to serve that from Flask. And that was super fun. I sat through all the workshops myself and followed along. We got some recordings of them, so that was good. But from there, I hadn't really sat down and used it beyond that. So we had some basic review of like what's a tuple, what's a list, what's a dictionary, and whatnot. But I never actually went through and used that stuff. And certainly, working with the data set and working with Flask and DOS and stuff like that, you're not really grappling with the syntax of Python a whole lot. So you may use the dictionary or something, or you may use the occasional list method or something, but you're not really working. You're not really getting your hands super dirty with the intricacies of like sets and tuples and lists and that sort of thing, loops and whatnot. Advent of Code is excellent for that. So whenever you're going through these solutions, like for like even day one, where they give you this math problem, usually that's pretty boring to do in code. But the way that they give you these problems, so like calculating the fuel for mass, you've got to write an algorithm that does this. And for this one, you don't really need to use data structures or anything. But by the time you get to like day 2 or I think 3, actually. Yeah, 3, so crossed wires. This one's having you find like a path or follow a path. I forget what the input is for this one. Yeah. So this is like 2 paths of wires. And so like if you follow this path, one solution to this is to do algebra, which is what I did. And so I went through and I basically captured all of these lines. So like write a certain number of spaces, that's a line with a certain slope. So I went back to basically middle school algebra to solve this. But another way to do this, once I solved it and started talking to people, was to just get each point and stuff it in a set. And so what I had done or tried to do originally was to use lists for this, or arrays in JavaScript, lists in Python. And traversing a list is, so that was great practice in Python, first of all, but also like a really poor thing to do for performance for this puzzle. So with a set, you can really quickly find whether or not something is in a set, where in a list, you have to traverse the whole list to look for something. So the speeds of those become very, very different, especially when you get up to an example like day 3, where you've got all these points. So like if you notice, this first instruction is to go right 1,000 times. That's 1,000 points or coordinates on a graph. And by the time you get to an end, or to the end, you've probably got like tens of thousands of points. So you're doing a list and you have to compare these 2 lists. So you've got like tens of thousands versus tens of thousands. That's like a nested for loop. So if you multiply the 2, for each point, you're doing 10,000. So looping through both things in a nested for loop quickly gets out of hand. Whereas if you're using a set and you're like, hey, is this point in this other set of points? Yes, no, it's very fast. So stuff like that. Before, when I was trying to learn Python, like I didn't really care about sets because I had never ran into a problem like that. But quickly with Advent of Code, like me and sets became best friends. I had never needed that in my day-to-day as a JavaScript programmer. Most of the data that we're working with is like a handful or maybe a couple hundred at the most points of data. But for Advent of Code, they're throwing thousands or millions or 100 trillion points of data at you, and you need to calculate that. So that was something that was brand new, and it really got me to use a lot of the features of Python that I really didn't need to reach for before. So when I came into Advent of Code, I kind of looked at JavaScript and Python as pretty much the same stuff, except one used curly braces and one didn't. But walking away from it, I still feel like they're both high-level languages. But they've got their own unique data structures and their own unique syntax for getting things done. So, like creating a 2D list in Python is really awesome using list comprehensions. And list comprehensions themselves, like going through all those workshops, I think Michael mentioned one of those once, but I never got to write one myself or reach for one or need one. And just doing that on your own outside of any problem is a very boring thing to do. But if you're doing it in the pursuit of solving one of these advent of code problems, it's really fun because you're reaching for stuff that you may not reach for every day, and getting to do that is a blast, especially when you're learning. So I think that these would be fun even if I had done them in JavaScript. Certainly, I think because of the way that JavaScript is not great at handling numbers, I ran into that on like day 2 or 3 or 1 or 2. I think day 1 I ran into it where I was trying to do something in the console, and it gave me like an off by 2 answer. And so what had happened is JavaScript's really funky about floats, and so I think floats and big numbers. So what happened is basically the way that JavaScript works, it gave me an approximation of the answer instead of the exact answer. Python doesn't have as big of a problem with that because it compiles like directly down to I think C or C++. So it handles that stuff intrinsically a lot better. But yeah, long story short, I learned Python. I learned how to use sets and why they're useful. I learned dictionaries in Python and when I would want a dictionary versus when I would want like a list. So they can both function very similarly. Looping over them both is a little bit weird. But in Python, it's kind of awesome. And then once I learned how to loop over a dictionary in Python using like, let's say dictionary dot items, I looked up object entries in JavaScript and kind of learned how to do that, which was neat. Using for in loops in Python, I looked up for of loops in JavaScript and learned about those a little bit. So even learning a different language, I learned more about my primary language, which was really fun. And then as far as like algorithms and stuff, so there were a couple of days that really required those different algorithms. One of them was Dijkstra's. So day 18, which was a maze puzzle. So we go down to the end here. They give you this giant maze for day 18. And on a previous day, I had done another algorithm, but for this one, it requires you to find, first of all the keys, right? So the lowercase letters, but then like the correct combination of collecting the keys that ends up in the shortest path. So for Dijkstra and that algorithm, I ended up looking it up. It's how to solve like a graph, and not like a bar graph or anything, but like a graph of different points. So to go from one point to the next point, so like from the start to B could be like one point on the graph, or from the start to Z could be another point. Like, okay, you travel to B and you travel to Z, and then you look at, okay, from like Z to O, or from B to O, how many steps does it take for each? And then you can do a comparison there. That's like the traditional Dijkstra's algorithm. For this one, I just basically like moved out in a direction. And so from here, like I create 4 different paths that can go in 4 different directions. And then from there, so I basically am creating the graph as I go. From there, I have like a branch here where I can go left or right. And then I've got a branch here where I can go right or up. And so like every branch creates a new path until I basically have created that set of different paths that I can take until I've hit all the dead ends and collected all the keys. And then find the shortest path to each key. And then from there, it's like which path is shortest and what are the possible paths to other keys. But so that's like the first Dijkstra's algorithm is just finding something like what's the shortest path to one key if you branch out every time that you hit an intersection. Um, but then there's like another Dijkstra's algorithm where you're looking at the different combinations of keys that you can collect in what certain order. So I feel like I really got a good solid education on pathfinding and like how to traverse a maze in programming, and certainly like how to do that algorithm, but also what I described where I'm like moving out in each direction and like forking into a new direction at each fork in the road would be considered like a breadth first search where you're doing like a wide search for your algorithm. And so I started using that for day 18, but on day 15, they give you a maze where you don't know what the walls are. And so you've got to like, you can see like if you start here, you don't know anything. And if you try and move up, you hit a wall. Or if you go right, you hit nothing. And if you go up again, down, or right, you hit another wall. So you've hit a dead end. So for that one, I think a solution would be far less performant to do that algorithm that we just talked about, which was like a breadth first search. So for this one, it's more of like a depth first search. So you're trying to go to the end and like go all the way until you hit a dead end, and that would be like a depth first. And then what I wrote for this one was like backtrack until I hit the previous intersection and go a different direction, and keep going until I hit a dead end or all the dead ends. And so I learned like all three of those basically. Maybe not a perfect understanding of Dijkstra's algorithm. Certainly, I could solve an easy like graph problem with that, but like certainly breadth first search and depth first search, I've got a solid understanding of thanks to Advent of Code. Not that I sat down and like watched videos on those. I did for Dijkstra's a little bit just because people kept saying it, but because I had to implement them. So I kind of got like a working knowledge of them, which I wouldn't have gotten otherwise because I'd never get to do any of this stuff. And then as far as math, like we talked about for day 3 with the crossed wires, so I brushed up on some line math from like algebra 1 in like middle school, where you're looking for like intersections of different lines. The only difference is this is working with line segments, so I had to do a little programming algorithm to kind of mash all that together. And then talking to people afterwards, they were like, "Oh, you didn't even have to do that. You could have just used a set to store all the points." So my solution ran pretty quickly because of the math that I used, but I hadn't touched that math in years. I think I got as far as Calculus 3 in college because I was doing like an engineering major at first. And I liked Calc 3. It was good. But when I got to differential equations, so like all the computer science math kind of comes after that. So differential equations, discrete math, linear algebra, those sorts of things come later on in the curriculum, and I kind of bailed out before then. And so for day, what was it, 3, I was kind of in good shape. If we're working with XY coordinates, 18 with the mazes and stuff, visualizing those was not a huge problem. I really got more comfortable doing that and working with like pixel locations because for like an image in JavaScript, you would consider the top left 0, 0 as far as pixels, especially like working with canvas, and then the bottom right would be the highest values of those. So if you're working with a 2D list of points, like the Y value gets higher as you go down, and the X value goes higher as you go right. So it's kind of the same thing. I really got comfortable working with that, which was awesome. So if everything's on a 2D plane and we're doing like that sort of thing, lines and whatnot, I'm right there with you. But when we got to like 16, this one isn't as much of a math problem. I mean, it is at the end of the day a math problem, but this is more of an algorithm thing, and the observation of how this algorithm behaves. People say that there is some kind of like super nerd territory solution for this, having to do with I forget. Basically, the giveaway was like you can use something to do with frequencies, some kind of math solution for that. I don't know what any of that is, so I needed some help with recognizing this pattern that eventually leads to the solution, which is that you don't actually care about any of these numbers until you get to the 1. It's like times 0, 0, like everything times 0 is negated, so you don't have to loop over those. And when you're working with like trillions of points or lists that are that long, so they repeat this 10,000 times, you don't really need to, like, just doing that is going to slow down the algorithm. So this was like another math one. Not really any particular branch of math because it's all just addition and whatnot. It's more of a pattern recognition thing. But day 22 is like, well, this is the deck of card problem. The numbers that they give you are massive. And so you have to know modular arithmetic to do this. And so that's something that, like, I've used modulo as a developer, but I've never really had to do anything complex with it. I've certainly never had to reverse a calculation that I modded. And that's kind of what you have to do because they ask you about what is the number of the card that ends up in position 2020. So you need to go backwards and like unshuffle the deck or reverse these operations they talk about. And so a lot of people complain about this one, myself included. But this is dealing with a branch of math that's really good for cryptography and also super low level programming. So when we're talking about like large integers and stuff like that, modular arithmetic seems to come into play. And some of the people that work on these problems and are in the Reddit had basically come out and like explain the solution in a bajillion different ways. I don't know if I have that pulled up. Here's one of them. So somebody came through and like, this is a logical way to do it. So like if you deal into a stack, that's reverse the list. If you reverse it twice, you don't have to account for anything. They're saying like if you can boil these down into, what they say. Basically, you only have to worry about multiplying times a position, or the position times a number, or adding an offset to that position. So they kind of like show you how to reverse these operations. So to reverse these two, you would do a negative cut and then do another deal into stack. Translating these into reverse, deal into a stack, and then deal with increment, you would do a cut -1 and then deal into increment -x. So this one was like super mathy. Somebody on Reddit, aside from this person, came out and wrote some blog posts on this person's phenocene. I don't know how to say that, but they were really nice and wrote a modular arithmetic for beginners. I've started to read this. It's very hard to read unless you are a math person. It takes a lot of concentration to sit down and process all of this information. Modular arithmetic is not easy by any stretch. If you're anything like me, when you start seeing this kind of thing, where you've got factorials and imaginary numbers or real numbers or whatever, actually, imaginary numbers start with I. Factorial is the one that has the exclamation point. But in any case, whenever you start seeing that, or that, or a... So this is the general intro to modular arithmetic. Seeing equations like that kind of make my mind melt. And then this is they wrote a blog post for day 22 part 2 specifically. And so they get down into geometric series down here, where you're trying to compose each iteration through the shuffles. And so there's that sum notation. When I see that, my mind just turns to mush. So I haven't had to do this math for years. I worked a little bit with sums. I think that's what that's called. Worked with those in Calculus 2. That was way back in 2005, so 14 years ago. I haven't touched that stuff since. I've just never needed it. So, working with geometric series and stuff like that, this math is super high level. This is way outside of my field, I want to say, and way outside of my normal day-to-day life. So, not being a mathematician, not working with super low-level code, not working in cryptography, this one was a real stretch for me. So I'm trying to read this when I have spare time and process this information. I know I've learned at least a couple of things about modular arithmetic so far. Like there is no division in modular arithmetic, so that's one thing to know. But yeah, learning math from Advent of Code was not the goal. I'm doing my best, but definitely had to cheat like crazy for day 22. So that kind of brings me to the low points. There were a couple of times in Advent of Code where I absolutely did not feel good about it. I thought I was done. I thought I had lost. I was toast. So those were days 4, 16, and 22. On those days, I was stumped totally, completely, and wholly. Sometimes because of math, sometimes just because I'm dumb and I had a really stupid solution that I was trying to force my way through. So, going back to the problems themselves, day 4, like one of the first days. So I made a video for each day, and you can go back and watch each of these in this playlist. But day 4, this one got my goat pretty good. I got really mad at this problem. I think I was like chewing a pen, and while I was trying to think about this, like I got so angry thinking about it that I bit through the pen. So rip that pen. But anyway, my problem was trying to parse these numbers in a particular way instead of like I think I was slicing the string of numbers into groups and trying to parse it, where somebody was just iterating over the list and keeping track of the amount of doubles or something like that. So I had to look up somebody else's solution on Reddit and look at their Python and see what algorithm they were doing to actually get the solution. And once I did that, I got the answer like instantly. So that was a real low point. I felt really stupid after looking up that answer, and I felt just dumb. The other one was day 16. So part 1 was really straightforward. It was just like do the thing, follow the directions. Part 2, where they give you all the examples and stuff, I was trying to do some weird algorithm for this and making it way harder than it had to be. Basically, I already talked about it earlier in this video, but you're kind of negating these numbers that start with 0. But the way that this trick works is if you loop backwards through the list, you only have to add. So like if you're starting here, you only have to add it to that number, to that number, to that number. So you're going to start with 8, and then 8 plus 1 is 9. 9 plus 5 is 14. That gives you the 4. 14 plus 5 is 19, so that gives you the 9. And if you're only working with the second half of the series of numbers, that's all you have to do to calculate each number for each place. And I was trying to do like the second half plus the first half and trying to find some crazy pattern that would work for the first half of numbers. But what they tell you is that in part 2, you are working with an offset. And so you're going to skip a certain amount of digits. And so if the first 7 numbers are that, you're going to skip that many places in the number. And so what ends up happening is, let's say that this was the final number, you skip everything except for like the last digit. So like that would be what you're actually processing. So the algorithm above that we're talking about, that first half, you never even calculate it. So it was totally useless to do that. So finding that that combination of observances like made me feel dumb because I didn't find them on my own. Somebody on Coding Blocks told me how to do it basically and was like, so you got to do this and you got to do this and you got to do this. And once you realize all those things, the problem is count backwards and look at like n minus one or whatever as you go backwards and add them together. That was another low point for me. I felt really stupid not having seen that on my own. I probably could have come to that solution on my own eventually, but trying to get through all these problems and get all these videos made put a lot of pressure on me to try and solve these as fast as possible. And when you're doing that, that's a surefire way to lose. Last one that really got my goat was day 22. I felt really cheated by this one because of the complicated math that it causes you to do. Because of the size of these numbers that they tell you to work with, it's impossible to do the solution with programming the naive way. So looping 100 trillion times over a list that's 100 trillion cards long, it'll never finish. You need like a terabyte of memory. You need years, like literal years of processing time to get this done. So the solution is this complicated math that I talked about earlier. So there are some eggheads that are doing Advent of Code with me, or were doing it with me, that knew how to do this, and I've read their explanations, and I still don't get it. Like, I have a high-level understanding of what it's doing and how it's supposed to work, and how you're supposed to boil these equations down. Basically take these operations like deal with increment 7 or cut 8 or deal into a new stack. Those can be represented mathematically to give you the new position of the card. And then you have to get the inverse of that using modular arithmetic and then boil down those equations, which are, I think, linear congruence equations or something like that. Basically, you can take all of these and boil them down into a single cut operation and a single deal operation. So it's like you take all of your inputs, all of these inputs, boil them down to a single deal and a single cut, and then you have to figure out doing that operation multiple times, which is where that geometric series comes in. Do that a certain amount of times, and then once you do that, you can then like flip it and get the final answer, which is the original card that ends up at position 2020. So that is way outside of my comfort zone and understanding as far as math. So that made me feel dumb again. Not a high point. I felt like pretty down the next day after having to cheat on that one and move on. Really hard on myself for not getting that on my own, even though I don't feel like it's possible for me to have gotten that on my own. Like if I sat down at my desk and tried to solve that just with the knowledge that I have of math, I basically would have had to invent that branch of mathematics myself. And that's asking a bit much for somebody that is trying to do a code puzzle, you know, for fun. So those were real low points. But balancing that out, there were a lot of high points in doing Advent of Code. So I had some really fun times solving some of these problems. In particular, a couple of these days, day 10, this monitoring station one where you're blasting asteroids. I had a lot of fun doing that one. So I'll see if I can bring up the solution here. So for day 10, that was monitoring station. And what I ended up doing was animating this so that it actually animated the laser destroying the asteroids, because you're supposed to find out what the 200th one is. And so I went ahead and animated it to completion, but that was a super fun day. I really enjoyed that problem. Even part 1 where you're trying to count like which asteroids you have a line of sight to, that was super cool to think about. Again, like the 2D X and Y coordinates and stuff, like I don't know why, but I've always wanted to do game programming, so I feel like this got me a little bit closer to that, so I really enjoyed it. Day 12 had nothing to do with that. This was very much just a basic math algorithm problem where you're doing some operation to recompute the position of all the moons. Part two asks you to do this for a very large number of minutes. So they want to know how many steps does it take to reach the first state that exactly matches the previous state. This was my answer, so this is like in the trillions. So you can't run this simulation that many times to find a previous state, even if you find a tricky way to save this as a string or something in a set. You basically have to do the math for it. And so one of the insights was realizing that the system must repeat itself at some time, and also that the x, y, and z values have their own independent loops of positions. So it then became a problem of finding the least common multiple, I think is what I'm looking for. Least common multiple of all three x, y, and z's multiplied together, or something like that. The loop sizes multiplied together. So I was able to come up with that on my own after reaching for some formulas for doing that with programming, calculating the greatest common divisor and least common multiple. That was awesome. I felt pretty dang good about myself being able to solve that, even though those math concepts are middle school math or elementary school math. Doing that with programming is not as easy, especially if you're not doing it on a pen and paper. So that was a fun one. Day 13 may have been my favorite one. Care package. So this was an int code problem. But if you actually run this one, oh, we're talking about 13, yeah. So this was a care package. This one was an actual breakout game in the terminal. So you didn't have to render this like I did, but I went ahead and rendered it anyway. You can actually manually play this if you wanted to. Most of the work for this is not done by me. Most of this is done by Eric, who created this problem. But this, just being able to do this in the terminal and like see this and solve this was super fun. Once I got int code working with the actual input and being able to render the output, certainly the animation I had to put the work in for. But I guess the combination of Eric's program that's actually running breakout and doing the collision detection and stuff, and my animation, it just produced this really cool result. I thought it was super fun. I really like this problem. We won't let it go to completion because it'll take a while, but that was a real fun one. Another one that I enjoyed was the maze problem on day 15. So we talked about that one a little bit as far as the algorithms, but the animation for this came out really cool. So I was really proud of this one because I wrote an algorithm to recalculate the max and min size of the grid so that I could print this without actually knowing how big the maze was. And that was like a really good moment where I was patting myself on the back, like, yeah, I actually solved this. That's super cool. So I really love this problem. I feel like I made a cool algorithm to solve it. I was able to observe that the pathways in this were only one space wide, so my depth first search worked really well for it. It also worked really well for finding the oxygen tank itself in part 1, and happened to work for part 2, where we're looking for the greatest distance from the tank to a dead end. So that was another really fun day. Some other ones that I liked were set it and forget. For this one, they give you like a pathfinding problem again. I really like this one because this one you didn't actually like the fast solution was not to do it in programming. the fast solution was to map out all the points, which I did with like my MS Paint skills after screenshotting the terminal paths and drawing on them. So this was like just pure puzzle. It didn't really have a ton of programming to do with it. This was the final maps that I landed on. But that was like really interesting and kind of taught me that not everything can be solved with programming. Aside from that, 18 was a fun one to do. That was like a really difficult one, so just getting that one done was like an accomplishment. It was another maze problem. 20 was a really fun maze problem. Being able to take that knowledge that I learned from day 15, apply it to 18, apply it to day 20 was really fun. I got to implement a different algorithm for searching. And then doing like this recursive problem where you've got the same maze that fits inside this inner maze using these portals and stuff. It took a long time to code it, but just like I said, just being able to get this was like really awesome. Another one that was frustrating but also fun was the Spring Droid problem, where you had to create some kind of logic program. I think this is, I want to say this is Boolean algebra, where you're saying like not and or and stuff. But basically, you have to write a script that gets the droid to solve all these special cases where it needs to jump over holes and stuff. When I first did this one, I was super frustrated with it and angry with myself because I couldn't understand Spring Script, which is the proprietary coding language of this only, like, it only applies to this problem. So my first instinct was, I don't care about that. I don't want to learn Spring Script. And then once I sat down and like, okay, I'm going to write down on paper what all these mean and translate it from the conditional logic that I'm familiar with as a programmer to this program, Spring Script, I actually got the solution. And then also the code for it ended up being pretty neat, because I was able to write like my own interpreter for this Spring code file. So I added like comments, I made it ignore spaces, and then it takes the script and turns it into inputs for the program, which is really cool. So I enjoyed that a lot. And then the last one, Planet Discord was like the last one that we actually had to apply like real programming toward, doing like recursive calculations of like bugs in this grid. That one was super fun. Not because doing recursion itself is fun, but because thinking about the logic of like how that looks at all these spaces, and then this space looks at another grid inside that has all those spaces. I don't know, like doing this and finding a good solution for it was like a good challenge just in like writing all these helper methods and calling the helper methods inside of other methods or functions, and composing all of these together to get one function that that makes sense in the end and gets you the answer was a ton of fun. And of course, the final choose your own adventure game. I feel like the Spring Code example built up to this one a little bit, because I wrote like my own automated script to play the game, which was fun. So all of those were fun. There was a lot that I didn't mention because there's like 25 puzzles. A lot of those were also really fun to solve. Not as interesting visually because you couldn't print something really cool for them. Some you could, but all of them, aside from the ones that melted my face off in difficulty, were like brilliant ways to learn Python. So I really enjoyed that. But with all that said, who is this for, and would I do Advent of Code again, and who's it not for? So if we check out Eric's about page again, he talks about people are doing this for speed contests, for interview preparation, training in university, for practice problems, or just for fun. Um, as far as fun, I had a ton of fun doing it. There were days where I was depressed and felt bad about myself and felt dumb as a programmer. But there were a lot of other days where I felt like, man, I really nailed this. People in my house were like, coming to check on me because they'd hear like a yeah or something, or like me clapping my hands really loud and going woo whenever I solved one of these. Uh, so there was like two extremes, like intense like appreciation and joy and like pride and in finding a solution, and then like the depths of despair whenever I was too dumb to get it or just wasn't familiar with a branch of math, or tried and just couldn't get it. Um, so if you he talks about not needing a computer science background. I feel like that's true because I don't have one and I finished it. A little programming knowledge, I call shenanigans on that one. You definitely need a lot of programming knowledge. You definitely need to know how to work with the basic data structures. You need to know about conditionals. Object-oriented programming and functional programming saved my bacon a couple times in this. So like working with int code, for instance. So I've got a wrapper function that calls int code. So this is like function composition that saved me. Being able to pass functions as arguments, being able to understand scope, reaching out to other variables in a higher order function. All that stuff made that a lot easier. And then on other days, like day 23, so another day using int code, using classes, object-oriented programming, that really helped a lot. So I don't consider those a little bit of programming knowledge. I consider that a intermediate amount of programming knowledge. Certainly not a little bit, but you definitely need problem-solving skills in spades. Oodles and oodles of problem-solving skills, but that's a good thing, and this will improve your problem-solving skills. So that is good. If you're a beginner in a language, I don't recommend doing Advent of Code. If you've just, so let me qualify that. If you have just started learning programming itself, stay the heck away from this. This is going to absolutely bake your noodle, probably make you feel very discouraged. But if you are like me and you've been doing a programming language for a while, like JavaScript or Python or whatever, and you've got a lot of experience with it, feel comfortable programming, you understand the basics, you understand how to write conditional logic, functions, variables, work with the basic data structures available in your language, this is a great opportunity to improve your knowledge of things outside of your comfort zone. So how to work with data sets that are a lot larger than you're used to working with, really putting the screws to some of the data structures that you're used to working with. So as a JavaScript person, like I use a ton of arrays at work and in my daily programming, but arrays are super bad, or lists in Python, super duper bad for some of these solutions. If you're doing like a nested for loop over, or looping over two arrays at the same time and both the arrays are massive, your program's never going to finish, especially if your arrays are like tens of thousands of data points long. So sets are great for that. Comparing two sets together is a very inexpensive operation, even if both sets are huge. But I would never have learned that unless I had done Advent of Code. So, I mean, maybe I would at some point, just reading the internet or something, but actually learning it and experiencing it and having to like implement it is something that Advent of Code provided a tremendous opportunity for. So that was awesome. Would I do it again? I'm not sure, because at least I don't know if I would pursue all 50 stars again. That was a huge undertaking, a lot of pressure to do that in a reasonable amount of time. I didn't get a whole lot of side project work done while working on Advent of Code because it took up all of my time. If you look at the leaderboards and stuff, These folks that actually got the top 100, they are super duper smart. This guy, Jonathan Paulson, has a YouTube channel where he does all of these. But if we look at this is a data visualization of those top 100 people and how long it took them to do the problems. So they are solving these in some people within like a minute, but some of them took hours to do. So the harder problems took them, some of these people at least, almost 2 hours to do, or a little bit over. This is not representative of the general public doing these problems. I know like day 18, for instance, took me almost 4 days to do. Like thinking about it, coming and like in an afternoon, spend an hour or two on it. And then the next day, think about it for a while, come back to it in the afternoon, do another couple hours. It just didn't come together in 2 hours. Most people are taking like days to solve these. They're working on them for many hours and then finally coming to a solution. And that was the same case for me. Especially when I first started, I didn't know anything. Well, I won't say I don't know anything about Python, but when I first started, I didn't know as much about Python. I hadn't written any Python programs. I sat through those workshops and learned a little bit about how Python works, but that's very different from actually writing code. So this is like the first time I've written Python code in earnest. And so these first problems, even though they were easy, they took me some time to get through and actually learn the syntax and stuff. So like up to maybe like halfway, I was still struggling with the intricacies of the language, getting stuck on not necessarily the advent of code problem, but just learning how to write what I was trying to do in Python, coming from how I would do it in JavaScript. And then by the time I got to like day 24 or day 25, I was like whipping through some of these problems and doing like maybe 2 hours for day 23, and maybe like 2 hours for day 24 or something like that. Just completely blazing through them. I know the top people here took 45 minutes to do it. But like we talked about, like day 24, where you're doing like recursive algorithms on 5x5 grids, that is a hard problem to think about. And having to code for that and make it understandable is super difficult as well. So that definitely took me a little bit longer. So would I do this again? I'm not sure. I think maybe next year I'll be ready for it again. I don't know if I would devote the amount of time that I did this year to it. I certainly don't think that I'll try and tell myself like you're going to get all 50 stars by Christmas or like a day after Christmas. So I don't know if that's realistic for most people. It didn't feel realistic for me. I was definitely putting a lot of time into it. But I learned Python. I learned data structures and algorithms. I learned a little bit of math that I really didn't care to, but I learned it anyway. So the payoff for this is immense. After doing this for like 27 days, I feel comfortable in Python. I feel like I could drop down into any Python course and learn like Django or Flask or whatever, Pandas, and actually understand what's going on and be able to read the code and stuff, and be able to navigate a program. So that's almost invaluable. Being able to pick up a second language like that in less than a month. So I really can't complain about that, and I'm super thankful to Eric for putting Advent of Code together. Also, very very helpful. The other people that did Advent of Code or helped make it. So these other folks, Tim Gianetti, Ben Lusek, JP Burke, Aneurysm 9, Andrew Skalski, and these community managers, Danielle and same fellow Aneurysm. Thanks to everybody that put this thing together. This was super awesome and a great way to learn a language, having had experience in another language. Also, big thanks to Coding Blocks, the community, Chris Biscardi's community, and their Discord channel for rooting me along, and also the Orlando developer community for helping me on a couple of the days that I was doing this. So that was instrumental to me getting all the stars, and also helped kind of like helped me make some friends in a couple of different communities that maybe people I wouldn't have talked to otherwise unless we were doing Advent of Code together. So, um, yeah, A++ would do it again if I have the time. So that's all I've got for this one. Thanks for watching all these videos. Thanks for sitting through this retrospective, which I did not plan for it to be an hour long, but it ended up being an hour. So I apologize for the length. But yeah, like, subscribe, comment, tell me how you did on Advent of Code. Check out the podcast at TechJR Podcast on Twitter, or techjr.dev is the website, where we talk to some of the folks from Coding Blocks and from talk to Chris Biscardi, we talked to Jason Langsdorff. Talk to him not about data structures and algorithms and stuff you come across in Advent of Code, but about stuff you do real life as a web developer. So a lot of helpful things, I think, so far, and also a lot of career tips and whatnot. So definitely check that out. All right, that's all the talking I'm going to do for today. See you later. Check out some of the other tutorials that I'm planning, and have a good one.